Welcome friends! In this video I'm fulfilling a dream from 6 years ago when I bought the truck, and I'm building a frame cut bumper for the Raptor. The twist here is that I'm making it a winch bumper also, which makes this project much more complicated. This project started back in December 2025 with me attempting to figure out where the hell I could fit my Badlands Apex winch and still get additional approach angle from cutting the frame. I realized that it would all be about compromise as I started ordering the steel, tools, and parts to get at designing the bumper. Once everything came in, I began tearing apart the front end to get down to the frame horns. This included pulling off the skid plate, removing the front hitch that I originally made for the winch, disconnecting the lights, and pulling off the front bumper with the tow hooks. Next, I pulled off the grille cowl, the headlight trim, and finally the grille itself. With enough space, I cut off the welds on the frame horns, which popped right off on the driver's side. It was like way too easy, like scary easy on the driver's side. The passenger side actually had good welds, which took a while to cut through though. Now I could test the template that I made in Fusion 360 for the main winch plate supports. These supports bolt to the bottom of the frame to ensure that the thickest part of the frame held the load. And that's where the two frame sides basically overlap on the bottom. I used the template to mark the grille because I realized that if I wanted more approach angle, then I would have to cut up into the grille. I picked a line in the grille that I could follow to cut cleanly and make it look natural. This just happened to barely work out, and I'll show that in a bit. I already had relocated the intercooler, which required me to cut out the grille louvers, but since I was cutting more, I knew I'd need to relocate the camera wire and the washer hose. After separating the two parts of the grille and moving everything out of the way, I could actually start cutting. With the grille cut, I reinstalled it to test fitment of the winch. I immediately realized that the winch clutch was in the way, and I would need to cut off a little bit of it, and that was surprisingly difficult. I had to make sure to leave enough space for the charge pipes to flex. It was a tight fit, but it would go. Next, I verified fitment with the support template before committing to the plan. I drew out the design onto 1/4-inch plate and set up a guide for the plasma cutter to follow. This was the first time that I used a plasma cutter, so it was definitely interesting. After cutting out the design, I marked the bend points and threw the support in my new finger brake. Then I drilled the mounting holes with my mag drill and annular cutters before doing the same thing for the passenger side. I ordered a dual pull winch plate from Barnes 4-wheel drive, which was 33 inches wide. The distance between the two support plates was around 29 inches, so I had to cut a bit off of either side to center the winch properly. Oh my god, I was so happy with the fitment here. So happy. But I still needed to test it with the actual winch, so I threw it on and lifted it up to check it all out and make sure that it was looking good. I tacked the winch plate into place, drilled that extra support hole into place. I needed a flat location for the skid plate supports to mount to, so I added a couple of scrap pieces to the bottom of the winch plate, and I added gussets because I don't trust myself and my crappy welds. Back in the garage, I cut, bent, and drilled some 3/16 plate to use as a lower bracket for the skid plate supports. I added some fancy bolt protectors from Barnes 4-wheel drive and bolted them into place. After getting the angle, I cut the 1.5-inch tubing and went through several iterations to get it perfect. I copied the other side and tacked everything in. I needed to keep those brackets in the right spot, so I got the angle from the supports and I used my new tube notcher to cut out a cross support down at the bottom. I had literally just assembled the notcher and this was my first cut, and the support fit perfectly. Again, because I was scared, I added some extra supports which could help support an impact on the skid plate. I wanted to add a cross bolt into the support plates, so I marked out the hole locations using a center punch. Two additions to this bumper that I wanted to add were a main tube for the sides, so kind of like wings, and recovery points for the front. I based the location of the tubing off of the recovery point, making sure that the recovery point opening would actually clear the face of the bumper and allow me to weld the recovery point to the supports, to the face of the bumper, and to the tubing, which I would run through the side supports and gusset on the inside also. I also used this time to mark options for cutting the frame. I made one mark to keep as much of the frame as possible, but it looked a little wonky, so I made another mark that would cut it as short as possible while maintaining a nice look. I pulled the bumper off and laid it on my 3/16 skid plate for marking up and cutting it. I also marked up an area for bending, and I used my new dimple dies to mark out cut locations. These holes were to make it look cooler, I guess, but mainly because I knew this bumper was going to be super heavy and I thought the holes would help reduce some weight. Cutting the skid plate was very easy, but I tried getting fancy with the dimple die holes using the plasma cutter, and I ended up making a huge mess. When bending the skid plate, I realized that the swag finger brake in the Harbor Freight 20-ton press had some major limitations, just based on the width, but fortunately it still barely worked out. To make mounting brackets for the skid plate, I tack welded it into place on the bumper and cut out a bunch of brackets from my remaining plate. Then I drilled a hole in all of them and figured out a way to make all the bends match on the finger brake. Also figuring out why Swag was trying to sell me those stopper bolts. It's for this, to make sure that you make multiple bends exactly the same over and over again. I wanted countersunk bolts on the skid plate to keep them flush, but that meant that the plate would need to be thicker. I made some extra plates and lined them up underneath the mounting brackets before tacking everything into place. Then there was a bunch of drilling and countersinking and cleaning up my crappy plasma cuts before finally pressing in the dimple dies on that skid plate. With a few clip nuts and some countersunk bolts, the skid plate was finally mounted. Next, I drilled the main tube holes and crossbolt hole before tacking in the recovery points and finish welding a bunch of stuff. Next, I made nut plates for the mounting points and decided to try out the plasma cutter on the frame. I seriously have scars from this. No idea why I thought laying underneath melting steel was a good idea. Anywho, I reinstalled the bumper, made some cardboard plates for the frame covers, cut them out, bent them, and tacked them into place. It's been like 2 weeks at this point, working 3 to 4 hours after work each day and using my wife's car. I finally had to drive the truck, so I fixed the wire and hose routing on the grill and reinstalled everything, including the winch and the new offset Fairlead, which was absurdly expensive. The next day, I drilled the holes for the crossbolts and started working on the main tubing. And I have an affordable bender, which, as you can imagine, does not mean a bender that can do everything necessary, because it's just affordable. Like making bends within a tight radius, which is what's needed for matching the lines on a Gen2 Raptor. I spent hours testing, measuring, bending, and trying to get it all to work properly. But if you try to start a bend inside of another bend, then the metal can actually start shaving off of the sides. And then when you go to pull the tube out, it will run a shard of steel straight through your hand. After crying to my medic and trying to figure out the bend again, I realized that I would just have to cut it to make it work. I used some spare tube from another project and put it inside to add strength to the cut point. Then I welded it, ground it down, and figured out the best way to follow the line of the trim and keep it far enough out to still protect the headlights. Again, I'll admit that this is primarily to make everything work within the limits of my bender, and keep only one cut in the tube. I didn't want to do multiple cuts. But it also helped make sure that the bumper was still a bumper, and it was far enough out and it protected things. Next up were the tube supports, which I imagined running off of the main support plates, but I found that it worked better off of the frame caps just because of how far back the wing went. Then I added 2 additional supports to clean everything up and kind of box around the frame caps. I had hoped to fit all of the lights in a similar position to stock, but that just wouldn't really work. So I came up with a plan to keep the fogs low and in line with the frame caps, while pushing the driving and spotlights up higher, but out of the way of the camera and the cruise control sensor. After adding the light mounts, I actually thought it would look cool to add some sheet metal to the side wings. I had no intention of doing this originally, but I thought it would look cool with some dimple dies, and the sheet metal would help keep dirt and wind out of the engine bay. I also made up some reinforcement to the main tube, which I had planned on using dimple dies on. I'm not going to lie, this was actually really difficult to get right and make sure that everything matched up on both sides. When I was done tacking and marking everything, I had to tear it all apart again. I did some cutting and finished welded all of it. Additional note here, I forgot how hard it was to weld sheet metal. It's actually a lot harder when you're running 0.35 wire and you're too lazy to switch to something smaller. Anywho, I added some cross tubes for the cross bolts using random scrap metal since I ran out of real tubing. And then I tacked in the mounting nuts. Also, cleaning it up and then painting those. Sweet Jesus, that was a lot of work. And I also used a tubing sander to smooth out the cut point before cleaning it all up for hours using a wire wheel, abrasive disc, and acetone. Then I added 5 coats of roll bar and chassis paint and let it cure for 3 days. In the meantime, I made some extensions for the light pod adapters to make them reach the new locations, and decided to weigh everything before the install. I did some last-minute additions to the bumper, including trim guards on the wings and skid plate, before awkwardly installing the heavy bumper. I ran the wiring for the lights and got them all installed. Then I moved on to the winch and the skid plate. Only after I did all of this did I start thinking about how to actually power the winch appropriately. The Badlands Apex winch can take over 400 amps to power, so I needed a 500 amp fuse, and I wanted the power to be run through a relay. I came up with a sheet metal design which required loads of bends and dimple dies to make it stiff enough and small enough to fit behind the battery. With everything installed on the plate, I spent around 4 hours putting together this nightmare setup with a 400 amp inline fuse from the 370 amp alternator running to a bus bolt, which distributes power to the battery and the two 500 amp relays, which in turn run power through 500 amp fuses to the house battery charger in the truck bed and a splitter for the front winch and 350 amp Anderson connector. To add to all of these wires running everywhere, I bought a wired winch extension mount from Ironman 4x4, and after verifying fitment, I drilled a hole in the driver's side wing and mounted the winch cable extension using rivet nuts and stainless steel hardware. Weeks later, I had time to test the winch finally, and I ran myself through the typical scenario. The problems that I ran into included a difficulty finding the tree strap because it was tucked way in the back of a drawer in the deck system, behind the tailgate, and behind the tire swing. So it took a long time to get there, and I also didn't remember where it was. Turning on the winch was the easiest part, and I did that just by flipping a switch I connected to the 500 amp relay under the hood. Then I used the wireless controller to loosen and pull out the winch cable. I still had to disengage the clutch, which I could reach, but it was not easy. After pulling the winch out, I set everything up and ran back to engage the clutch and start to winch. And of course it worked perfectly fine. Alright, so final thoughts on this are that it took way too long to make this thing. I kept asking myself why I wanted to add the winch and just wishing that I had made a simple frame cut bumper. Aside from the time that it took, I spent so much money on tools thinking, this is my time, and all these tools will make it so easy. Now, I couldn't imagine trying to cut all the steel without a plasma cutter, but a home hobby setup requires way more than I expected and still has major limitations. Only being able to bend 19 inches at a time with the finger brake is a problem. Only being able to bend 1.75 inches max and only on a 7-inch radius for the tubing bender is a problem. Only having a few annular cutters was a problem. Not having 4-inch deep hole saws was a problem. It's just wild how many limitations I had to work around and how long it took despite spending thousands of dollars on tools just for this project. It cost around $600 for the steel. I got the Barnes 4-wheel drive stuff on sale for the holidays and spent about $120. The winch I bought a long time ago and that cost around $450. But the Fairlead I had to buy new because the dual pull plate needed to vertically mount the winch to the face requires me to use an offset Fairlead, which I didn't have, and it cost $250. Wiring, hardware, and paint was probably another $200 altogether, which means that just the materials for this bumper, minus the winch, was around $1,100. So for the weight, the new bumper is about 32 pounds heavier than the original bumper, but when you add the front hitch, the hitch mount, and the winch to the equation, we save around 32 pounds for an operational winch setup. It's still 100 pounds heavier than just having an OEM bumper, but now I have an option for self-recovery. So the bumper has some design quirks due to packaging requirements. The light locations are a little odd just because I couldn't keep them in the normal location and I had to lift them up higher. I'm glad that they can still clear the front camera and don't interfere with the adaptive cruise control. I did briefly consider a stinger on the bumper, but that's just more weight and for no real purpose other than to kinda look cool. The dual pull winch plate was a requirement because I needed to tuck the winch up as high as possible, and the controller would have been up in the intercooler if I had kept the standard orientation. I just happened to make it barely fit, but I did have to grind a bit off of the full race intercooler mount supports. The decision to use paint and not to get it powder coated was just based on cost, and I ended up spraying everything down with Amsoil metal protector to prevent rust. The bumper is flat and it eats up rocks on the highway, so I think I might end up having to repaint the front quite often. Wiring was insanely complicated and it definitely looks like a fire hazard, but everything is assembled well. I think that the Anderson connector is kind of silly now. I bought the connectors and the 2-aught wiring for the front and rear with the expectation that I would use it with the hitch-mounted winch that I had before, but even though I ditched that plan, I still decided to add the connectors. This is really kind of a solution without a problem. The only thing that I can think that I'd use it for is to connect jumper cables. I did not measure the approach angle beforehand, which has to be a little different from stock just due to the lift springs in the 37s. But after the bumper, I'm at 48.1 degrees. I think that this is a little difficult to measure though, so I'm not really certain about the measurement. I think that the biggest thing for me was that there was value in just doing the project in the first place. I learned that I needed to heavily bevel 1/4-inch material for good welding, and I learned that anything 3/16 and above has thick mill scale, which I need a better solution for than just an angle grinder with an abrasive disc. In using the winch, I realized that the rear tire carrier hinders use of my storage compartment, and I might want to, figure out a way to store the recovery gear elsewhere. Anywho, that's all I've got. Thanks for watching, and I'll see you next time.